This ballpoint pen is used to write light-emitting diodes, or LEDs. The pen is just a pen, which is uniquely used for this project. But what's so special is the form of ink that's high-tech. It's being developed inside this Washington University in St. Louis laboratory.
When people think about the light-emitting diodes, they don't think of that as something everyone can make. The cell phone screen, the computer screens, they're all light-emitting diodes. 5-10 years down the road, people will be able to go to any store, buy a pen similar to how they buy the normal pens that they use, and they will be able to write light-emitting devices on all types of objects that they use in daily life. And the pattern that they wrote on those objects then become a display to display the information they want.
That's Chuan Wang's vision for LED displays, personalized displays used for many things, starting with handwritten notes. Wang is an associate professor of electrical and systems engineering at the McKelvey School of Engineering. He says the research in his lab will make it possible for anyone to make their own light-emitting devices on any surface, including the stretchable rubber glove.
The reason you are seeing the device being translucent is because it's unfinished. To make the LED, we have to go through all the processes. In the end, when you are done, the color, those are the ones that you will be seeing. The translucent ink is only the starting point. If you think about LEDs, the iPhone screen, right? They are built on glass or on plastic films. And we have shown that we can make the LEDs on any type of substrate you can come up with in daily life.
So, just how is this possible? First author, Junei Zhao, is a doctoral candidate in Wang's lab. He formulated the material into a solution, which becomes the ink. The material is layered, stretchable, and flexible.
Just 4 layers, 4 different materials. The most bottom layer, named PWPSS, is a polymer, conductive polymer, so it can be used as the bottom electrode. On top of it is the most important layer, light emitting layer, named the perovskite, from blue to green to red. And on top of the light emitting layer, we use another buffer layer. So buffer layer, the role is protection. And then on top of this buffer layer, we use another electrode. It is silver, it's metal, it's conductive, but it's just in the form of nanoscale wires. So wires entangled just form a network. It's stretchable, it's flexible.
The flexible and stretchable optoelectronic devices are good for use on paper, textiles, rubber, plastics, and 3D objects. You can find a surface, even a portable one, to draw, then fill for the creation of a display of any size and shape, used for apps and watching videos.
I have to admit, there will be a trade-off for sure. Due to the low-cost way of making the displays, of course, the resolution will not be as good. Will nowhere be close what you can get from a commercial screen. But not all applications require very high resolution, high pixel count.
When the material for the ink is completed, a power source would be needed.
A low-cost display, so if there's a battery inside, it can be powered. Or if there's a solar cell, for example, printed or attached, that can provide power to the device. It can light up.
There are commercial, everyday uses, such as package delivery.
Write a label on top, and that label actually works as a display. For this type of display on smart packaging, and after that, the ink can be washed off and can be reused for the next round of shipping applications.
And there are biomedical applications.
For the healthcare applications, we're not selling the pen. Actually, we're selling this idea how to quickly wrap up a functional device.
The field has a growing demand or interest in developing personalized wearable devices to track the health.
For example, a smart bandage.
Personalized health monitoring applications.
And the smart bandage technology can also be used to help heal wounds.
Illuminating the wound with infrared light can actually speed up the healing process.
And there are some cool applications for education.
Science popularization helps to pique the interest, especially in the young kids.